Hello, everyone. Can you hear me all right?
Hello, hello.
Hi. So I propose we wait minutes to see if more people join, and yeah, then we'll start. Um, welcome to the people joining. Hi, everyone. Just to warn the newcomers, we are waiting one more minute to see if more people join, and then we'll start. Okay, so I don't see more people coming. So I think we can start. So this is the agenda for today. Um, and we'll start by discussing um, 2780, so reduce intrinsic transaction costs. And Guru will give us an update on the status of the specs and test implementation. Guru, if you want, the floor is yours.
Yeah, no, thanks, Maria. Yeah, so on EIP 2780, on the specs and test side, we've got a draft implementation and some basic tests already written. So where we are right now is there are some interactions with, so basically the current implementation is likely to break some of the legacy tests, particularly those around 7702 and 7928, the BALS tests. So we need to kind of fix those before we can make any test release. But that's kind of a lot of tests that we need to fix. So it would be good to kind of clarify how these interactions, there are some interaction points which I don't think are fully clear from the EIP document. So ideally, we want to make these test fixes once, not having to go back and forth and like keep fixing them again and again. So I have raised kind of a PR to the EIP's repository to attempt to clarify this, or at least like start discussion on some of these interactions. And once those are clear, we can fix those tests and potentially look at making a release. But the EIP 2780 specific tests are already in the draft PR. So on that front, we are pretty good to go. I can also link to the PR if necessary. This is the PR from the EAPS repo.
So Ben, do you have any comments?
Yeah. It also needs the addition of the log prices from EIP 7708 because they're currently free. However, the assumption there is because the gas prices of an ETH transfer are so ridiculously high, the logs can be free. But since we're bringing down that cost massively, we should add the log prices on. Since essentially the CIP is saying, pay for the actual costs and break it all down, and they should be included.
Yeah, that's a good point. do you think you could add a PR to include them, or
Yeah,
or I don't know.
I can follow up
Sounds good.
if
Thank you.
you want me to.
Yeah, that would be great. Cool. Any more comments for Guru? So I think he linked the PR. I'll urge everyone to review and see if you find any issues there. Yeah, I linked a few people already with some questions. But yeah, go, Guru.
Yeah, just a quick point. I think this would be for Tony, if he's on the call, regarding BALs. I think account access kind of becomes cheaper if you're attempting to access only EOAs here. So if he wants to take a look, if there are any like implications on that for the BAL size
Yeah,
in particular.
this is interesting. Yeah, how much cheaper will it get? So today it's 2,400. That's the cheapest you can access an account. How much cheaper will it get?
So if you're attempting to access a cold EOA, the charge is 500. So you're essentially 25%.
Okay,
An important
this is quite
point
significant.
there is this value may also be updated after we have the numbers for the state access EIP, so 8038. So it's possible that it will increase a little bit, but still it will likely be a reduction anyways, due to just benchmarking out the benchmarking results we've been seeing from e-transfers benchmarks. But yeah, so it's something we need to think about.
What's the interaction there? Sorry. How does it affect BAL?
It might affect the worst case BAL size.
Okay.
So this is one of the things, and yeah, there's also currently some discussion around how to quickly invalidate BALs, which also uses currently the 2000 gas, because that's the cheapest you can access storage key / account. But this sounds like it will be reduced to 500 then.
Exactly. What are the next steps there, Guru? Do you want Tony to just have a look again and comment on your PR?
Yeah, so I mean, that's not a blocker per se. The next blocker would be to kind of agree on how we want to handle, yes, the 7702 gas charge and like the points that I've raised in the PR. Once we have clarity on how the final clarity on how we want to handle those, I can go back and fix the 7702 and 7928 tests that are currently being broken by these changes. And that kind of gives us a good test suite to possibly make a release.
Yeah,
Perfect.
I think you're correct on that additional charge, because you have to look up the account.
Mhm. Yeah, so ideally, just to summarize, the next step would be to get this PR clarified and merged, and then I can proceed to take that result and update my implementation and fix the breaking tests.
Sounds good. So I would ask. So I already gave a quick read and added. So I pinged you, Tony, and Ben. So if you could just go there and just do a thumbs up or something like this, just to make sure that everything looks good, then I can approve it and we merge it. Sounds good. Perfect. Anything else we should discuss regarding the transfer EIP, or should we move to the next point?
Yeah, maybe just to add to that. So intuitively, this tells me that the ball size will probably increase quite dramatically, right? Because if we quarter basically the cost of accessing an account, right now, of course, the storage keys are the main contributor to the ball size. But then I would also assume we have to look into, okay, we lower it to a level where the ball size gets bloated, so we might need to make it more expensive again because they also contribute to data. But basically, sending one way to as many accounts as possible will probably be the new worst case ball size.
Again, I think on there, maybe we can wait to have the preliminary numbers on 8038 to understand what would be the actual costs of accessing cold accounts with code and without code. And then we can do the math of recalculating the worst case balls. And if we feel like that's an issue, then it just means that the state access EIP will have to add some sort of additional cost for the data part.
Yeah, sounds good. Let's do that.
Perfect. Any more topics on heat transfers EIP, or should we move to the next topic? Going once, going twice. Okay, I think we'll move to the next topic. So for the next topic, we'll be talking about state creation, gas cost increase. And here we have two topics. So first, I wanted to raise a question that actually Dragan from Red first raised, and I think kind of made me go into a rabbit hole of how to deal with the subcalls and the reservoir mechanism. So I wanted to present you the options and just open the discussion on that. And let me just open it because I have some slides. Okay. And then after these, we'll have Spencer will give an update on what he's been up to for the specs and the tests for TCIP. Okay, so I just wanted to explain what is happening now in the how we deal with gas metering in subcalls and what are the open questions. So just so we are all on the same page, so the current way that the EIP is doing the multidimensional metering, so it is splitting up these two resources. So we have the state creation operations, they spend state gas. So this is not the state access cost, but the pure cost of creating new states. And then all the other costs are the regular gas. And how we are metering this is we have still the gas left, as we have now in the EVM. And this gas left is essentially bound by the transaction gas limits, so the 60 million gas units. And then because for state creation, users can use more than these transaction limits, they have this reservoir. So whenever their transaction requires more than the transaction limit, this extra is set to this reservoir. And then what happens is that the gas left, so the state creation transactions use the reservoir, and then once the reservoir is zero, they start using gas left, while the regular gas can only be taken from the gas left. Okay? And then what happens in calls? So in calls, the user is still specifying a single gas value to use in the call. And so the question is, we need to define first how does the forwarding happen? So how much gas left in reservoir will the call have access to? And then what happens both in the success case, so how are the unused portions returned, and also what happens in the failure. So in a revert, an exceptional halt, how much gas is returned to the gas left in the reservoir. And so I try to kind of describe as much as possible all the options. So option one is essentially when we are in a call, the gas left is the G that is being sent, of course with the 6364 app. And the reservoir is essentially all the reservoir. Okay, so when the user says the call is using G, that G is passed through the gas left, and then all the available reservoir is available for the call. Under success, the stuff that is unused gets returned, and both on so on the revert, again, gas left is returned, and the reservoir that is unused is also returned. On an exceptional halt, this is where it's a bit different. So here, all the gas left is consumed. So this is to keep consistent with the current design, but the unused reservoir is also returned. And the rationale for this is that when we have an exceptional halt, then all the state that would be created is actually not created. And so if we were to spend the reservoir, this would be too punishing for users. And so this means that actually we should return the reservoir. So this is option one. Option two is very similar. So the forwarding is the same. Success is the same, revert is the same. But then on the exceptional halt, we are saying that both the gas left and the reservoir are zeroed out. Again, this is what is more in line with the current behavior of the exceptional halt. But again, I think it's too punishing for cases where we have an exceptional halt, because we would be spending all the reservoir which was made available, right? And we would be zeroing it out. So it seems a bit too punishing. Then option three, the change is more on the forwarding part. So for the forwarding, we are saying we are not making all the reservoir available, but instead we are making the same proportion that was available in the gas left, we are making the same proportion for reservoir. So if the call is with G saying I want to send 20% of my gas left to the call, then we also send 20% of the reservoir. And then the success, revert, and exception halt behave as the same as in option one, which is less punishing than option two. And then we have option four. So this one, the only change is again how much of the reservoir is being forwarded. And here the idea is like you don't forward the same ratio, but you forward the exact same value, right? So if you say I'm making 20K available of gas left, then you also make 20K of reservoir available if it's available. Like if you only have 10K, then you send all the available reservoir, but it's not a ratio, it's the exact value. And I think this one is a bit more in line with the current way that multidimensional metering works, where you say there's a block limit of 10K, let's say, or there's a block limit of 60 million gas units, and you can use up to 60 million gas units of both resources. So this is actually a bit more similar to how multidimensional metering does it at block level. And then success, revert, and exception is the same as option one. So what are the trade-offs? So it seems like in option one and two, you do have forwarding is a bit simpler. You have access to the full reservoir. But also this has the problem that G doesn't give you a bound on how much the call can spend. So this could lead to weird behaviors where you are just saying, I just want to send G to my call, and then you end up spending a lot from the reservoir. And so this is a bit, it's a bit worse for untrusted calls. And an option 2 here is even worse because it's like if you end up in a out of gas condition, then you even get your entire reservoir wiped out. So I think clearly between option 1 and option 2, I would prefer much more option 1. Then option 3 and option 4, they give you a bit more control over how much you are spending via the G. But it means that you may have to send bigger Gs if you want to use more, if you want to create states during your calls, which also comes with its own issues. Then you have like the option between 3 and 4 is more like what would be more intuitive for users when they are setting up G, and what would be easier, which I don't have like a strong intuition there. And so I wanted to just open the discussion. If there are any comments in the call, great. If not, I will also share this async so we can start the discussion. But I think there's here the question of how should we define these semantics? In my opinion, option 1 seems better. Option 1 seems better than option 2. But we should maybe think a bit more and see like, is this really true? And then are there any additional problems with any of these options that we haven't thought about? So yeah, happy to hear your comments on this. And if there are any questions, also happy to go into it. Ben, do you have your hand raised? You want to talk?
Yeah, it's a little bit tangential to this, but does estimate gas need to change to provide people with like so we estimate higher based on the fact they could be charged more? Because we need to estimate above refunds, if that makes sense. Because otherwise it will go, can you pay the potential gas that you might spend?
I'm not sure I understand what you are asking. Sorry, can you explain that again?
With this EIP, is there a potential that you're charged more upfront, which is then refunded? So I'm wondering if a note should be made that estimate gas should be estimating like the higher bound, if you see what I mean. That what you could be spending, which might be higher because you're spending more on storage, creating accounts.
But sorry, do you mean like in the case of a halt and revert, where your reservoir ends up being wiped out, or not? No.
I don't mean with these changes you're highlighting at the moment. I just mean the overall EIP. In that, if we tell the user how much gas the transaction costs, then their transaction will get rejected because you originally get charged how much you could potentially pay, and then you get refunded back if you spend less, if you see what I mean. I'm just wondering if we need to put a caveat in for estimate gas to make sure it's estimating the maximum that you could be spending.
So I may be wrong, but my understanding is like the way that refunds work are not changing. It's true that gas costs will change, but this is true for all the other EIPs, right? Like for the heat transfers EIP, it's the same thing. Like gas costs will change, so we'll have to update the estimate gas. Paul, I don't see how these EIP is different from all the others on that respect.
Okay.
But I may be missing something. So please let me know if so.
On this, I do think we do need to. I'm not sure what's the right approach, but I do think we need to limit it, cap the amount. If the call is capped, then the amount of reservoir pass should be capped in some way else.
Right. Yeah, I think this is yeah. So I think this was a good raise from Drogan. Like I hadn't thought on that. But I think it's not obvious the right approach there. So Daniel, do you have any comments?
Yeah. So I mean, the idea of the reservoir or the problem it tries to fix is mainly to deploy smart contracts up to the new maximum, no? Because without it, it would not be possible with 8037. So,
Right.
I mean, we don't want to encourage people to create a lot of state. And you know, when you create a contract, I would say it's either directly in the transaction or maybe you do one sub call when you use a factory. But I'm not sure if you really have to worry about the issue that people have, you know, very nested calls and then create a contract. So maybe even option 2 is fine because either the contract is created successfully or it isn't. And I'm not sure if it really makes sense to allow people to have these very nested calls to use the reservoir, even though maybe there is a revert or whatever, because I don't know, maybe they can abuse it again in some form. So, as I said, I would say, you know, we should think what we want to do with the reservoir. And as far as I know, the only use case is to create new smart contracts. And that's it. We don't want to encourage people to use up a lot of state or to create a new state in any other way than that. So as I said, for me, draining all the state gas on a reward actually I think would be fine. But there might be some patterns for smart contract deployment that I'm not aware of that would not be work anymore and that work today.
Right. I think here the issue is mostly on the factories, which is what you pointed out too. I think these are the ones that need more state gas within nested calls. Yeah. But yeah, Drogan, do you have a comment there?
Yeah. Maybe I would even split this in like 2 problems. One is how to limit reservoir to the subcalls. Second one, not problem, but like discussions. The second one is what to do on revert and hold. In general, limit for the first discussion, maybe makes sense to limit it somehow. I like idea to limit it proportionally depending on what gas, regular gas is set, but I don't have strong opinions on any of that. Second discussion, I think it makes sense to revert, basically to refill the reservoir if basically the gas that should be used for creation is basically not used. I do think that previously we didn't have this option because we had just one gas and it was different state. But we could like make the difference between the the CPU work that was done, or maybe state work that was done. But because we are making this split inside the VM, I think it's a good idea to not charge for something that was not done. Yeah.
Yeah, I tend to agree as well. Yeah, it's just a matter of if someone can think of a problem with that approach. Yeah, I think it's one of those that we need to kind of stew on it and see if more things come up. Any more comments on this? Goldwish?
Yeah, sorry, Maria. Just rolling a bit back even on the problem itself. So since the state created is kind of rollback if there is a halt or a revert inside a call, do we really need to care about limiting the amount of state gas cost that is passed? Since I mean, we do care about the state that is carried across blocks, but do we care that much about the state that's temporarily created in the case of a halt or a revert inside the call? Maybe I'm
Yeah, I
missing.
think that's a good question, and I think this is where like the separation that Dragan did help. So I think one question is like on halt and revert, what do we do? The other one is like even in the success case, how much reservoir should be available for the call, right? And I think the second question is more about like if I'm a user and I want to like the reason why I'm limiting the gas that is being available in the call is usually a protection, right? Like if you are interacting with contracts that you are not too sure about, you want to have that control over how much gas is being charged. And so this concept of letting all the reservoir be available changes this, right? Like now a user says, I just want to use 10K for this call, but actually I could end up using 20K if I have 10K in the reservoir and my contract somehow like creates a lot of state. And my intuition is like, this is a bit like, it's a bit weird not giving the option for the user to kind of being able to limit also the reservoir. And under the two options, essentially, you'd still be limited by G. It wouldn't be exactly G. So for instance, in option 4, it would be G. And in option 3, it would be G plus the fraction of state gas that is induced by the fraction between. So it's a bit more complicated, but it still gives you some sort of like way to limit this. So I think this is the question is like, is this even something that would like users to have the possibility of doing? Because the simplest approach would be just to do option 1, like you let all the reservoir available, but then this comes with sort of some protection from the user side.
Yeah, in a way. Yeah, sorry, Ruben.
If you did option 1, it would potentially mean that you call a contract with a limited amount of gas, but they can burn all of your state storage.
But the compute part is like this, the SLOAD is or STOR is, there's also a compute side of that as well. So there's a state side and a compute part, and that is capped still with the current limits.
Right. I think the issue that like the way that you could do it more cleanly would be with like deploying contracts within the call.
Mm-hmm.
So you
where
might
there
want
you can spend much more state gas without execution costs. Sorry, Ben, go.
Yeah, because there's the pattern where you do, try catch. You can do like a try catch, and you might expect it to out of gas as the worst thing that can happen. But if it can destroy your reservoir, then that might limit what you'd expect to be able to do afterwards, after calling something.
Yeah,
Mm.
I think the
What-
create is a good point.
Yeah, what if we limit the reservoir only to create and create two and not the other, and not as store, for example? So this means when I call a contract, they cannot write at least their own state.
I'm sorry, Daniel. I think I lost
Oh,
the first bit. Can you say
yeah,
that
no,
again?
sorry, I'm just thinking out loud. But what if we bind the reservoir or only to create and create two and not to S store? So we really say the reservoir is only meant for creating new contracts. So this means when I call another contract, it could only use my state gas really to create other contracts, but it could not use it to write something to its own state, and it would need to use the normal gas for that.
How would that help with this?
I mean, this would help because the contract that I called could only create new contracts. I mean, yeah, it can still burn all your state gas. I mean, that is true. So this yeah.
Yeah.
Yeah. No.
Yeah.
Maybe it makes no sense. Sorry, I was just thinking out loud.
Yeah, but I think good. I think it's good to think out loud and throw ideas.
Yeah.
Any more comments on this? Go, Spencer.
I guess I'd ask, just for the sake of speeding things up, should we settle on one of the options now and then we can change like in the future? So maybe for DevNet 3 we pick an option, and then DevNet 4 we actually settle with either the same one or updates it to a different one.
Yeah, I think that's a good question. I think in my opinion, it's like clearly option 1 is better than option 2. And then the question of option 1 versus the other two, I think is a bit more nuanced. So I would say yeah, I guess like my intuition could be maybe we could start with option 1, which is the simplest one, and then we can think a bit more about it, and then we can switch it to option 3 or 4. What do people think?
Yeah, I think we should do this. And what we then do is we figure out what breaks, what can be abused. And if we then figure out that this is something what we don't want, then we have to change it.
Sounds good. So yeah, let's go with option 1. I will comment on the PR, Spencer, and then we can merge it.
There is one edge case related to option 1. It is you have parent call and sub call, child call. What if the parent call sends like 20 million gas? And then the child call basically has like 60 million for the regular gas and 4 million for the reservoir. Or it doesn't matter, it doesn't send 20 million, it just send like, sorry, example is not that great. Imagine sending like 1 million and reservoir that's like 3 million. But what if the child code is basically spreading the 3.5 million state gas on itself? What happens if that reverts? basically they did spend all the reservoir, and for the state gas, he additionally spent 500,000 from the regular gas. Should we, my idea that I had is basically we could refill basically parent coal, then get additional 500,000 on reservoir. In that sense, we are refilling full amount of state gas that was consumed by the child coal. Because the child coal consumed 3.5 million, but it had only 3 million of reservoir. I'm not sure if I explained it okay.
Right. No. I think that's a good point. So just to summarize, so the case is you had some reservoir, but you were in a call and you used more state gas than you had in the reservoir. So you have to spend also gas left. And then there's a revert. Then what happens in the reservoir will be fully reinstated. But the gas left wouldn't. So that would be spent fully. So
it should be spent.
It should be spent. So I think it's like in a revert, it doesn't matter what happens within the call, right? Like you still do the same as the gas left you sent with the call all gets used, and then the reservoir gets reinstated. So in your case, the 500 gas that you used for state gas that was spent from the gas left would also be reinstated. So it wouldn't be spent.
Idea is we shouldn't add it back to the regular gas, but we should add it to the reservoir. Then at the end, the parent coal, after the child coal reverts holds, it would have, it had 3 million reservoir, but after revert, it would have 3.5.
I don't understand why. Why should it have 3.5?
If we want to not spend all of the state gas, we should add it somewhere. So we could add it back to the regular gas, but this seems bad in the sense that we are like splitting the gas that was spent on the state is now added to regular gas. So better option is to add it back or add it to reservoir. Or there's option just to ignore it and just say if the gas that is basically the state gas, if this consuming regular gas, then this part of the gas is going to be deleted, not reverted. Or
I mean, maybe we should just do this async and write down in Spencer's PR. But my intuition should be that yes, those 500 would go away because you were sending a certain amount of gas to the call, and on a revert, that amount that you sent should all go away, independently if you use it for state creation or not. But yeah, let's discuss this async. Sounds good. Okay, so maybe I would link the PR here for people who want to see, and for the next point, Spencer, do you want to give a quick update on what you've been up to for V37?
Yeah, I can be fast. So I still have the same specs PR as last week. I believe I've got option 2 implemented from the previous discussion, but right now I'm trying to fill all the existing tests that we have in deals with the spec implementation, and I have ran into quite a lot of issues, mostly surrounding the gas limit for transactions. So I think we hard code the gas limit in a lot of the transactions in the tests. And with the new state gas dimension, this gas limit is very low in a lot of the tests. So there's a lot of the tests need that increase. But some of the tests also have some other interactions with. So I guess also with the tests, we need to make sure they're refillable for every fork, right? And with 7825, we have the transaction gas limit cap. So it's also trying to make some of the tests fork aware so that we're not breaking any previous filling of the test. So I've been working quite heavily on that. So far, I think I've fixed from Frontier to Shanghai, and then it will be Prague, Cancun, Osaka, and the Amsterdam tests. I have not yet tested the legacy tests as well, and I think those will need to change. So I think it might be a bit of extra work from our side. We do have a internal Steam call after this call, and I think I will ask for some extra help there from the team. But yeah, that's the update from my side.
Thank you. Thank you, Spencer. Are there any questions for Spencer, or should we move to the next point? Okay, I guess there are no more questions. So the next topic is on 7976, so the increased call data floor costs. Tony, do you want to give a quick update on that one?
Yes, I'm happy to do so. I just posted in the agenda the ETH research post I recently had. I already brought this new pricing up in the last ACDE and ACDT, so it's nothing new, but recently we changed the pricing from 1560, so 15 for 0 bytes, 60 for non-zero bytes, to 6464, which means at the floor cost, users would pay the same gas per byte, no matter if it's a 0 byte or non-zero byte. I already updated the analyzers that is linked in the EAP, and instead of affecting 1.5% of transactions, this would affect slightly above 2% of the transactions. So most transactions are still like unaffected, and the rationale behind this change was that in the worst case scenario, so for worst case blocks, it doesn't actually matter that much if it's a 0 or non-zero byte, because you can otherwise use 0 bytes. You would maximize the number of 0 bytes because they are cheaper to get like the max size block, and just making sure that they cost the same, 64 gas per byte, ensures that this doesn't matter in the worst case. So I'm curious if people have any opinions on that. In the ETH research post, you can see if you scroll down, I created this chart that projects like what the worst case block size will be with that change. And yeah, so this gives us some room for scaling, ensuring that the worst case block size won't be a problem that soon again. Of course, until at some point we have to do something more sophisticated with the call data pricing anyway. But this is like diffusing the situation, I would say. And the worst case block size, so with the pricing that we had earlier with the 1560, the worst case block size would have been at 3.5 megabyte compressed size. And with the 6464 pricing, we will get down to slightly above 2 megabytes in the worst case compressed block size. I've already started like reaching out to the affected parties. There are not many. Like most users can use blobs anyway for posting data. It's only those that can't move to blobs that still need their call data to get inside the EVM. And it's only a few parties that are affected. Right. So if there is any objection or anything, I'm curious to hear it.
On the 64 value, I don't have an opinion. I'll defer to you. On the 0 byte being the same, I think it makes sense because if you're doing useful work, then most of your bytes won't be zero. So it's only the people most affected by it will be the ones essentially filling the blocks with nothing.
Right, exactly.
And not doing useful work.
Exactly, yeah. So this is maybe I should have added that previously. The call data price for everyone who will not hit the floor will stay at 416. So it's very well backwards compatible. So most users won't feel any difference. It's only those that hit the floor that would actually pay the 64.64.
Yeah, thank you, Tony. I can't think of any issues. I think it's makes sense to change. But yeah, if anyone has some time to take a look at it and has any additional comments, please forward them to.
Tony, I'm just wondering which entities are affected. Are these like protocols, like bigger ones, or?
Yeah, good question. So it's the same entities that were already affected by 7623 that introduced that mechanism. For example, among those entities, there is Polygon and there is Darknet. And for them, it's because they have very large proofs that they can't just post their data in blobs. So for them, they need the call data to actually, do some math with the data.
Okay, maybe
those are the main users. There are some smaller users that is like negligible. It's like me sending you a transaction and saying hi Butter. So this is like the largest amount of users that are affected. Users that are just like saying a few words in their call data. But when it comes to like what is the economic impact, it's those protocols that can't use blobs that are still using call data. But
maybe
go ahead, yeah, please.
Maybe afterwards you can connect me with those and I can force them to fill out our survey.
Yeah, happy to do so. We are already in discussions with those anyway, but I'm happy to forward them the survey. I guess that's the proper way to do so. Yeah, let's do that.
Yeah, I would like. Yeah, I mean, I think it's gonna be my time anyway, right, Maria? In the agenda, maybe I'll take over then.
Yeah, maybe we can move to your section.
Right. So for those that weren't here last Friday, we introduced a new website which is called gasrepricing.com, and on this page you will be able to find everything related to gas repricing. It also links to the progress. So if you're curious what the status of each individual task is, you can find it here. You can find a simulator. This is more specifically designed for those that are affected. But more importantly, there is also a survey that would be nice if you or someone you know that might be affected could fill out. Because if you're not affected, you probably will just ignore it. So it's kind of hard to get data to just confirms the design of the current EIPs, but still having real data would be nice. For those that forget about the website, we also linked it at the top of Forecast, so it also is promoted here. And I think yesterday we also posted it on Twitter, so if you can retweet it, it would be great. I think so far we got like 2 or 3 official survey candidates, but I also manually reached out to Coinbase, Kraken, and one other exchange, because I think those are like most obvious stakeholders that will be affected, because they have payouts like withdrawals, deposits to exchanges, or they have other products. So while they might not be represented in the survey itself, they gave me like off-chain information. I will link it in the chat. So maybe you can retweet it. I saw Tony already retweeted it this morning, so thank you for that. Yeah, that's my part.
you, Buta. Yeah, I think this community outreach will be very, very important going forward to make sure that users are not surprised by the changes, and also that we take into consideration their feedback in time while we are implementing these changes. So yeah, I'll just reiterate, like, if you can share these, and if you know anybody that would be impacted, please share it with them. Are there any questions or comments for Buta?
So just for your knowledge, next thing we'll be posting it on Reddit, like eFinance. Maybe we can get like individual people to fill it out. I will also try to get in touch with Aave, because I think if they are fine, it's also going to be fine for other DeFi projects. And then maybe Tony can connect me with Polygon and the other folks that he was talking to. But yeah, as I said, like if people are fine, they tend to be quiet.
Cool. Thank you, Buta. And we are almost at the end of the call. There are no more topics, but I think if there are any questions or general comments or topics people want to bring up, we still have some time for that. So I'll just open the floor for random topics.
I had a question in the chat. Basically, is it true that the cheapest way to access, for example, if I call balance on an account, going back to 2780, if I call balance on an account that has no code, will this effectively only cost me 200 gas? Can someone clarify that?
You always charge at least the transaction based cost, which currently is 4,500. So, and that covers, let me just open it up so I don't say it incorrectly, but it covers EC recover costs, a state update costs, and the call account cost, no codes. So those three components are always charged.
Right. Yeah, Maria, you did an amazing analysis by the time, if I remember correctly, about the worst case ball size. So I guess we should just connect async to see what changes. But my first intuition would be that the new worst case ball size will be a transaction, a max size transaction that then calls, for example, the balance opcode at as many empty accounts that have no code as possible. And for each of those calls, you would only pay 200, but you would not only call the account, you would also do an S load, I guess. And then you would end up with 20 bytes from the address, 32 bytes from the storage slot, and you would only pay 2,600 plus the 200 gas. So I think the worst case ball size would change a bit, but yeah, let's connect async and clarify that.
Sounds good. Yeah, happy to do it. Are there any more comments or topics, or should we wrap up? Okay, so it seems there are no more topics. Thank you all for attending. Notes, recordings, and all that will be made available in forecasts. Yeah, and thank you for joining.
Thank you. Bye bye.
Bye. See you all in 2 weeks.
Bye bye.